Okay. Well, welcome to November 5th, 2024 session of TAPR and HamSCI technical session. My name's Dave, KV0S, and this week I actually got my rebuilt 3D printer to work again. And I've been rebuilding things that I knew worked. So I'm testing that. And so I'm looking forward to being back able to make boxes and things again. Anyway, um, next on the list, we have Nathaniel, W2NAF. And I must tell Nathaniel, I watched Gwen's talk and it was quite interesting.
Yes, thank you, Dave. It's been a busy week, and I guess the things that are most relevant to the project are, yeah, Gwyn gave a talk last week during the Ham Science Telecon, and it was very good. He gave perhaps one of the best detailed analysis of the grape type of data that we've seen so far. So if you have not had a chance to watch that video yet, it is on hamsci.org/telecons on the Ham Science playlist. You can find that YouTube link there. Um, I think otherwise, we're just moving along with W3USR and the different projects. Some exciting things that are coming up. Um, the in about 2 weeks, Gareth and I are going to Northern Virginia to the NASA um Act and Citizen Science uh, meeting, and so we'll get to meet in person with NASA officials who are interested in citizen science. And along with that, about a year ago, Gareth and I had Gareth led this proposal, put in another proposal asking NASA for more funding to continue the eclipse data analysis. And we've been told that that proposal was selected, and but they're very slow in getting the award out. But we're told it's in process, and so that's exciting that we're going to continue having funding for Kuldeep and for continuing to do analysis on the eclipse data. And then shortly after that, we're getting ready to go to the American Geophysical Union meeting in Washington, D.C. So we're taking care of all of the abstracts and things like that right now. And the AGU meeting, that is one that if you are interested in attending and you're in the DC area, there is it's a bit of an expensive meeting, but I think there might be some reasonable cost options for people who are more like citizen scientists or participants to attend, if not the whole thing, if for one day or so, and you can come see some posters and talks and things like that. So you can go check out AGU.org, American Geophysical Union.org, for more information on the AGU meeting. That's in early December. And we have we've got many presentations there, like 18 or 19 ham presentations that are going to be made there with like 91 co-authors. Mary Lou West put together a list of all of these, and that we're also developing a HamSci newsletter, which we're trying to get edited and prepared now, and all of that information will be in the newsletter. It'll hopefully come out in a couple weeks. So
Very good.
that's it. All right,
You've
back
been a
to net.
busy person.
Yes, always. Lots of help. Thank you.
Okay, next on the list we have Dave, KD0EAG. Go ahead, Dave.
Hello. Yeah, I hope my doorbell doesn't ring a bunch. The lightning is triggering my doorbell camera for reasons I don't entirely understand, but at least one of the doorbells. And I think it's just the flashes of light. We've been having a quite a little storm. Otherwise, I've been busy on several fronts, not idle, but um, not anything real exciting to report here. So I'll pass on, say good to see you all. Thank you.
Oh, Okay. Next on the list, we have Dylan, KN6 IVW. Go ahead, Dylan.
Well, nothing really, just sitting here doing more work on my Linux computer. Yay.
Very good.
I'll send it back to you, Dave.
Okay. Next on the list, we have Bill Engelkey, AB6.
Maybe for AJ.
Oh, I'm sorry. Go ahead.
Yeah, been working on several things. First of all, collecting all the data that is to be imported from Zenodo and the WWV club server, getting that all and together and organized in such a way that we can even think about importing it. We've got a lot of the files. We've got 63,000 files so far. This is data that's been collected by this group. And that needs to be imported. And we still need to figure out a schedule for moving some systems that are uploading to WWV and get them to upload to the Personal Space Station network. That's going to take some planning though, because their data is a little bit different. So we have to fix a bunch of software in the system that deals with ingesting new files such that the metadata and everything goes into the database correctly and all that. So, on another note, we've been thinking about how to provide some sort of an analysis page, particularly for magnetometer data, and trying to figure out the ergonomics of what is the best, would be the best way to give people access to this data. I mean, one process I can think of is you pick a date off a calendar, then up comes a map that shows you what data is available and where the stations are for that day. Then you can multi-pick some of those, and then it would show you the plots for a 24-hour observation for those ones that you've selected. I suppose it might also be possible to add eventually spectrum data so that you could do that. Now, the most sophisticated websites do this all dynamically, where they generate the plots as you while you wait and so on. And that's possible to do with CSV data like we have in a magnetometer, but it's not so straightforward for data that's stored in digital RF format, because getting a spectrum out of it is, you got to go in through the DRF hierarchy, and then you got to run FFT on the data, and you got to make sure you pick the right data, and there's a lot to it. So I don't know when we really do that on the fly, but there's other ways to. I mean, if you go with the happy standard, I think what we would need to do would be to take the spectrum data and make a précis file or a summary of it that's in CSV format, and that would allow you to do a quick look. But if you want to work with the data itself, then you probably got to download it. Anyway, if anybody has any ideas on how to optimize this, please contact me, give me an email, because I'd love to get your input if you have it. Okay, back to that.
Very good.
Quick comment.
Go ahead.
Yeah, so Bill, thank you very much for that update. Gwen Griffiths did send in one request formally, which I will forward on to you, for how to improve the website. And it's basically just asking for an API way of downloading the data. And he wants it very simply, where you can either use curl or wget. You can specify the station code and start and end dates, and send an HTTPS request for the observation data. So, I mean, I think it's a very simple way of basically implementing what we want to do for the happy things. But what I'll do is I will forward this on to you, so you can see it. And then maybe it makes sense. Maybe like you said, we have to create another either another working group or a workshop or something to kind of review what we want to do for all the website improvements and get a better plan for that.
Yeah. That's a big project. You know, you know how it is with software. Its scope can expand to fill the unknown universe. So you gotta be a little careful. But
Yeah. Do you have a draft scope already defined?
I believe yeah, I mean, what we did the proposal and
Mhm.
it's one, that's what we have so far.
Okay. Maybe I can talk to you more offline, but maybe there's a way that we could have you present it or have you take some feedback on it, or we can revisit that before we actually go and
Yeah,
totally implement that.
yeah.
That
that'll be
sounds
fun,
good.
sure.
Okay.
Okay, great.
I just also wanted to mention there's several new people here, and Bill runs a database service at the University of Alabama for the HamSCI uh, projects, multiple projects. And so while many of us have sat here for 4 years listening to these things, if you're new, it may be a little confusing what we're talking about. Okay, next on the list is, let's see. Clint, any comments?
Not really. Just enjoying the conversation.
Okay. Uh, next on the list, we have Dave H. W6OQ. Go ahead, Dave.
Yep, good evening, everyone. Yeah, my big project this week was watching the plumbers tear up my whole front yard to put in a water line.
Ooh,
Yeah, that was pricey.
I have done
Anyway,
that.
yeah. Anyway, so other than that, I'm just here to learn what I can learn and see if there's any way to contribute.
Okay. Next on the list is Dave Julian, WB9. Where'd it go?
YIG.
YIG. Just as I was about to read that, you turned on your mic and I lost you. Everything shuffles every time you change your mic settings.
Oh, nothing much going on here. Just survived the first day of getting the leaves up. It was an all-day affair, so I'll just sit back and enjoy the show. Back to the net.
Yeah, we're having leaves coming down here, but they're just kind of starting. Usually, end of October is our best color week of the year in leaves. Anyway, next on the list, let's see if I missed. Dave New in 8 SBE, sorry.
Yep, we're still playing the fly on the wall here. Yeah, I was just reminded that this summer we had our entire front yard torn up to replace the sewer line because almost everybody in our neighborhood has Orangeburg, which is that rolled tar paper that they
Oh,
used
yes.
after World War II because ductile
Ooh.
iron was in very short supply.
Yes.
And so the Ann Arbor folks, the Ann Arbor city was coming in here to repave all of the streets, and they said, if you got Orangeburg, fix it now because we don't want you tearing up our nice new streets later to replace it. So we had the entire neighborhood full of contractors replacing everybody's sewer.
Yeah.
So anyway,
I'm going to ask you a quick question. Do you have any contact with Michael AAK? He's somewhere north of you.
oh, really? It doesn't sound too terribly familiar to me, but
Well,
what's it?
he was
What?
a regular here, and he hasn't been around for a while. And I was thinking he might have gotten sick or something.
And what was his call sign again?
AA8Q.
AA8Q.
I think it's
Is
Q.
that right?
AA8K,
Oh,
Alpha
sorry,
Alpha
K.
8 Kappa.
Sorry.
AA8K. In Port Huron, Michigan. Yeah, he's
Yeah.
not really in my local area.
Okay.
Yeah. So, nope, sorry.
He's been an active member of this organization. Well, I've been on telecons with him since the late 2000s because we worked on the open HPSDR as well. So, and I haven't seen him for a couple of months, so I wondered.
He's got a pretty impressive QRZ page with pictures of his station, dating all the way back to when he was a kid, I guess.
Yes, yes.
November of '62.
So
Yeah.
anyway,
No, I'm afraid that I haven't talked to him.
okay, just thought I'd ask. Next on the list, let's see who do. Dave McGaw. David McGaw. Go ahead.
Hello. Yeah, all I can say to Dave New is go blue.
Well, actually, you say go Lions.
Yeah, that too.
They certainly like beat the snot out of the Green Bay Packers on Sunday.
Yeah.
And some guy, some announcer essentially said that the Detroit Lions was the best team in the NFC, and that just floored me.
Yeah. Well, my grandfather was a professor there, and my parents both went to the university, and I was just there going through my grandfather's papers a couple of months ago.
Yeah,
So,
yeah.
first,
Being in Ann Arbor, everybody recognizes that as the home of the Michigan Wolverines. So.
mhm. Anyway, well, I've been working with rheometers here. I'm wondering if at 30 megahertz I might be getting some third harmonic bleed through from the 10 megahertz that's running around. And I guess I'll mention another interesting radio phenomenon that I just noticed. A couple of weeks ago, I mentioned that there's a time in the evening this time of year that I can hear all 6 WWV frequencies
Yes.
at once. Well, this morning I found a new one. I could hear all of the WWVH frequencies at the same time as WWV.
Ooh.
From 2.1 all the way up to 15 megahertz. They were all doubled. But yeah, we're going to need to figure out how to discriminate between those guys. I guess that's about it. Back to Nat.
Okay. Next on the list is Doug, KF0PCW. Go ahead.
Oh, I'm just happy to be here. I was inspired. I was inspired by Gwen Griffith's talk last week. It was just a wonderful example of how to use those data. It just inspired me to think about maybe doing some project of my own with it. So it was really quite good. Otherwise, I'm just having so much fun listening and learning.
Yes. Well, we have people in this group with all different kinds of backgrounds, and you'll be surprised what some of us have done in past lives. So, but
Yes.
we all have a interest in using ham radio and using it to extend atmospheric science. So we hope you can find a niche and find something you were willing to work on.
Yes, settling on one will be the challenge.
Yes.
Thank you. Bye-bye.
Okay, next on the list, Gary, AF8A. Go ahead, Gary.
Yeah, good evening, everyone. Yeah, David's comment about receiving WWVH made me think about the propagation over the weekend was outstanding. I think the solar flux was in the 270s. It just happened to be a major contest weekend CW sweepstakes, and I was thrilled to make over 400 contacts this weekend, which for my station, that's fantastic because I only have one permanent antenna on 20 meters, and the rest are all Rube Goldberg lash ups. But anyhow, speaking of grape data and whatnot, I think 5 more Grape One DRFs are on their way to host as of today. The guys in New England, we had 5 return and 5 are going back out. And Bill Engelke, thanks for your help in getting the data they needed to configure those. So we'll be getting more data coming in soon, we hope. Speaking of the central control system, I took a screen grab of that over the weekend of the map of the United States in preparation for this NASA conference Nathaniel was talking about. And it was beautiful because almost all the pins were green. There were 5 or 6 of other colors, meaning either offline or possibly offline. And looking at it tonight, it doesn't look quite as nice, but for some reason I got a good shot over the weekend. Things were doing well. One other thing to ponder, we don't have to talk about it tonight necessarily. I've been noticing is I listen to emails and answer people's questions that come into the HamSCI mailbox. I occasionally send them over to the magnetometer page in the TAPR store. And Dave Witt may have seen some correspondence from George Burkett. There's a lot of stuff on there about how the magnetometer boards are designed to work with the Tangerine SDR. And I really think we ought to update that. And even on the HamSCI page that lists all our telecons and the Get Involved page, there's a whole paragraph about sending people to tangerinesdr.com. And
Yes.
I think if they went there, they'd be kind of disappointed because I don't think that's changed in a few years for obvious reasons. So I think we ought to think about either removing that stuff or updating it or I'm not sure what, but open to ideas.
Well, at least from the TAPR point of view, we like to keep a document of things we've done, whether they were completed or not. And but I think I actually have access to edit that website, so I'll probably put that the project is not currently active. I don't know of anybody that's working on it still.
And I
Tom was
think
kind of the last one to really be active.
I
Tom,
think from the HamSCI point of view, the thing to do right now is to basically sunset the links to the Tapper page because I don't think we're going in that direction. So I think the personal space weather station page should point to the Grape and to the Whisper Demon RX 888 and things like that.
Well, the PSWS page does. The only one, let me do a screen share real quickly. Let's see. Let me see here. So this is the page that I'm questioning, I guess, right now, because this is a pretty prominent page in the HamSCI world. People get here off the home page.
Mm-hmm.
So
can we get a link to one of the K9Q setup pages? I have one that's it's not as much detail, and then otherwise we jump over into Phil's GitHub.
Well, if you go to the PSWS page and you go to the RX 888,
I think the important part with that, if you go back to the other page, Gary, that the other one is the Get Involved page. The important part is understanding, like, this is where people can sign up for different listservs. And
right.
I think the thing is we're still using the Tangerine SDR listserv, right?
Yes, we are, but we will probably rename it. We just elected 3 board members a week and a half. Yeah, just over a week ago. and we're getting around to electing officers just before Thanksgiving. So, but then we'll be moving forward with cleaning up projects and our web presence. There's a few things we want to change, but we have 6 or 8 people that have a finger in it, and it makes it hard to
What
keep
I
it.
would say, Gary, for the HamSCI page is just to remove references to tangerinestr.com, but
Yeah.
you can still leave. So can you show that screenshot again?
Sure.
What if you just call it, yeah, leave it, you leave Tangerine SDR Tapper listserv, and then you can leave the part that says Tapper is an amateur radio organization dedicated to electrical engineering, and Tapper has teamed up with, let's see, delete the words that say tangerine, or just, yeah, just say, okay. Tapper has teamed up with HamSCI to design and build portions of the HamSCI personal space weather station, including new software-defined radios, plural, delete known as what they're known as well as a ground magnetometer module. And, actually, I would say just leave it for now, because then that still points to where people need to go to get to the Tangerine SDR listserv. And then I guess when Dave and Tapper rename it, then we change it.
Yeah.
I think that's the best. You can delete the part that says known as the Tangerine and Clementine SDRs, because maybe that's still up in the air. But I think the rest of it, until Dave lets us know what listserv we want those people to go to, I think we just leave it alone.
Okay, that's fine. Just these
Yeah.
6 words, then I'll change. That's it. Okay.
Yeah.
And
Great.
Gary, you
And
also got a
if
spurious letter A in that grammar. It says A and then something after that is plural, so.
okay, I'll figure it out. That's good enough for now. Thank you.
Okay. Next on the list, let's see. Jay, WB8 SBI. Go ahead, Jay.
All righty there.
Wake you up.
Just keeping the camera off to conserve bandwidth there.
Yes.
Nothing new amateur radio wise, except Nathaniel, I had a question for you, please. At
Yes.
the HamSCI conference at NJIT, I assume there's going to be a Saturday night banquet.
Yes,
Has
I
a
believe
banquet
so.
speaker, has a banquet speaker been chosen?
Not yet.
May I make a suggestion?
Yes.
This month in New York City, the Radio Club of America, and you can go to their website for more info. Their Saturday night banquet speaker is going to be one of the Nobel laureates that discovered the cosmic microwave background radiation.
Okay.
And he's going to be speaking there. So it occurs to me he might be someone we could contact to see if he'd like to come to our banquet, the HamSCI banquet, and be the Saturday night banquet speaker. I think that'd be a really fascinating thing to hear.
That would be pretty neat. I have a organizing committee meeting that I'm going to on Thursday, and I can mention that, and so we can certainly take that into consideration. So
Yeah.
we'll see.
Yeah. So website Radio Club of America, and somewhere on there, I think under events, is the meeting that's in a couple of weeks here on Long Island in Times Square in New York City, and also the contact information, how to get a hold of the organization.
Yeah,
Yeah,
it's
no,
Wilson that's talking.
Yeah.
Robert Wilson.
That would be really good. I think a couple things. First of all, I think the Radio Club of America meeting is going to be really good. I'm hoping to be able to go to it, but I'm also doing a bunch of travel, like a lot of travel for work over the next month or so. And with Thanksgiving and everything, it may just in the little kids, I think it may be too much for me to go this year, but certainly anyone who can make it, I really do recommend it. I think it's going to be a fantastic conference, and I can't say enough good things about them. So that's the first thing. Second thing, I think it's awesome having the Nobel laureate there and Wilson, and I think that's also fantastic. The third thing in terms of HamSCI's, yeah, we are still up in the air. We'll certainly take that into consideration. I think that is a good suggestion. I also, don't want to just duplicate what other clubs or organizations are doing. And so I may want to have someone complimentary or different, just because I don't want to do exactly the same thing Radio Club of America is doing. I think what they're doing is fantastic, but it may be valuable to spread some of these things around a little bit and give different people opportunities. So I think all of those things are going to be taken into consideration.
All right. Be prepared if you're going to stay at the hotel where the Radio Club of America is having their get together this year. Be prepared to spend $250 a night.
Okay, well, I think if I were to go, my mom lives in a subway ride away.
Ah,
Yeah. So, or I'd probably stay at my mom's house and then we'd probably, do a day trip of it. So, we might do something like that. But
also,
as I said, anyone who wants to go, I think it's a really, really great
one
meeting.
of the on Thursday and Friday, they're also having day trips, and one of the day trips is going to be out to the Bell Labs site where they have the horn that these guys use to discover the cosmic microwave background radiation. So that's a historic site. So I'm looking forward to all of that. And oh, by the way, parking there at the hotel is $70 a night. So yeah, yeah, they're going to get you coming and going. Fortunately, I have a relative that lives on Long Island, so leaving the car at her house.
Oh.
But uh, it ain't cheap, Trudes. It ain't cheap by a long shot.
Yep.
So anyway, that's all I had. I just wanted to bring that up to everybody's attention. Hope that everybody else is doing well and staying safe. And with that, I've got to go QRT and get on down the log here. I've got other things that need to get done tonight. So I'm going to say 73 to everybody. Hope everybody is well, and we'll catch you later on down the log next week. Bye-bye.
Bye. Next on the list is Joe, W7LUX. Go ahead, Joe.
Good evening, everyone. Seems to me those two professors spent a lot of time cleaning that big horn, trying to get rid of that microwave background noise. But nothing to report. The two grapes are cranking out data. Back to you, Dave.
Yes. Next on the list is Jonathan Ferguson, KB3DQZ. Go ahead.
Hey, how you doing? Just wanted to introduce myself. I'm a faculty at a little tiny college up in northern Vermont called Champlain College. I have a student group called the Free and Open Tech Club, and we managed to win a little tiny proposal grant award to join you guys doing some HamSCI work. So
Very good.
we'll see what the students are really wanting to do, but I wanted to show up and say hi and
thank you
make
for your email
myself
the other
known.
day.
Yes.
Yep. So that's what we're up to. We've got somebody kindly donated, and we don't know if it's going to work, a USRP2. And we're looking at getting the appropriate the TX and RX boards for those. But we're also looking at the RX 888 and some other options. So we're just in the early stages here of getting into it.
We strongly encourage you to look into the RX 888 and the K9Q and the Whisper Demon, because you have both the K9Q author here tonight and the
Hmm.
Whisper Demon author here tonight. So
Yeah, that's very cool. And I watched one of your conference presentations, or most of the conference presentations. I note that the playlist is in reverse order, which makes watching that conference particularly tedious.
Which one is that?
On YouTube, it was the one that was in the drama building. I don't remember. It had,
Oh,
it
that
looked like,
sounds like Cleveland, just in
Cleveland,
March of
yeah.
this year.
yeah, it was in March of this year.
We can
and,
probably get the playlist fixed.
yeah, it was. I was just like, no, I just saw that one. Have to pop out and switch to the next one to try and get it. So it was pretty confusing from a timeline standpoint.
Okay.
But otherwise, yep, I just wanted to show face that I'm here and we're trying to cook something up, and hopefully we can join in the fun.
Yes.
Yeah.
Jonathan, what town is Champlain College in?
Champlain College is located in Burlington, Vermont.
Oh, you are Burlington. Okay.
Yep, we're in Burlington, and
I'm sort of a neighbor. I'm at Dartmouth.
Oh, excellent. Hello. Yes. And we have we're professionally focused college. We are private, nonprofit. We do have some centers of excellence, or experience, or whatever you want to call it, that have been pretty popular over the past couple decades. And I teach one of those. I teach game design in the game studio at Champlain College. So
very good.
we have a bunch of other interesting majors, of course, not just that.
Yeah.
But it is particularly interesting from that standpoint. We have a bunch of students who are interested in free and open technology. So since the TAPR group is all over the free and open source stuff,
Yes.
I think that we will be of like mind in that endeavor.
Well, if there's things you need help with or who to talk to, please reach out to Nathaniel or or any of the group, actually.
Yeah,
So.
absolutely. Yep, I've already subscribed to the list, and I'm trying to provide appropriate guidance to the students. We're all undergraduates, right, for the students
Yes.
in ways, right? So
and all of my students are all undergraduates too.
Yeah.
So we've got quite a few undergraduate students working on the project. So we would be very happy to discuss ideas with you. And I do recommend in terms of just if you're looking for hardware to set up, the way to go is the RX 888. With running Whisper Demon and KA9Q. It's all fully open source, open source data and software. And I think it gives a really good platform for doing things. And I think, I'm constantly getting things that are like, can you expand it by doing this or by doing that? And, since it is Linux and we have the authors here, it might actually be something that you and your students could do. So like even today, I just got an email from Ward Silver saying, can you add monitoring the NCDXF beacons to that? And I haven't even had a chance to respond to that email or tell anyone about it. So there's
You just did, I think.
Well, there, I just did. So there's an idea. So what I would recommend, another thing that I'd put on your calendar is we have that HamSCI workshop. It's going to be in New Jersey this March. So we have the dates announced for it. So it's if you go to hamsci.org/hamsci 2025, there's a very meager webpage that just says that the workshop will be held March 14th and 15th at the New Jersey Institute of Technology. If you can put that on your calendar and try to get your students to come give a poster at that. It's a really good conference for students to go to. That's the same conference where you saw all of those reverse emails or reverse YouTube videos for, which I just emailed Jason Johnson asking him to fix that. And we have a lot of college students and especially undergrads go to that conference. So it'll be, and we've had the ARRL come, and last year they even had a collegiate amateur radio program meetup at the conference.
Excellent.
So
That would be excellent.
Yes, definitely put that on your calendar. And if you can make it, it's not a long drive from Vermont. So
No,
yeah,
just about 6 hours.
just about 6 hours.
Yeah.
Maybe you want to fly. I don't know.
No,
But
it's quite drivable.
It's very, I
drivable.
think you can ask anyone here. I think it's a very worthwhile conference.
Yeah.
All right. Well, I definitely thought so when I watched it.
Thank you.
Okay. Well, next on the list is Jonathan, KC3EEY. Go ahead, Jonathan. Jonathan, are you there? Oh, there you are.
Hi, everybody. I am the other Jonathan, of course. I've kind of been occupied with various non-VLF related activities. I meant to actually check up on the servers. So the server that the system uploads to over the internet, the webpage abilene.org is down. So the author of VLFRX Tools runs that. And I expect he's probably doing some maintenance, but the system that is recording the data, that's obviously still up, but the outward facing web page with event galleries, which allow you to view spectrograms and audio samples of various captured VLF events and other information, that's currently down right now. But I was going through the recent weaker geomagnetic storms have given us some whistlers and some dawn chorus, which is always very nice and very welcome. But there hasn't really been anything major with the storms that were visible, especially in the lower latitudes. But that's kind of the nature of things. That's one of the things that that's kind of a question that I would like to answer. Is why what is dynamic about the geomagnetic storming conditions that might create dawn chorus and risers from geomagnetic storms that other storms don't. So there's that dynamic part of the magnetosphere and the that responds to the input from the solar wind. But that's one of the questions that we would like to answer. Another application for VLFRX tools is bat detection. A lot of enthusiasts use VLFRX tools for bat detection. What they do is they input a downmixed ultrasound to audio converter, and they input that into a computer. Dave Kazan and I, we got to talking about that when at the W3USR station dedication. So that's also another interesting application. That's all I have. Back to the net.
Okay. Next on the list is Michael Howen, AC0G. Go ahead.
Good evening, everybody. Not much from here. Back.
Okay. Next on the list is Phil Karn, K9Q. Go ahead, Phil.
Hey, Dave. Same here. I'll pass and join later on.
Okay. And then next on the list, we have Rod Mitchell, KL1Y.
Hello, everyone. Yeah, Rob Mitchell's correct. KL1Y. I was licensed up in Fairbanks, Alaska. I don't know if I've been see yeah, if you guys see me here. But yeah, I was licensed up in Fairbanks, Alaska over 20 years ago. And um, well, I don't know if you can see me there, but anyway, I'll just say this real quick. And I was in the Army for 21 years and retired from the Army. And now I'm living in El Paso, Texas, still working for the Army as a systems engineer, designing communication systems with our soldiers using the battlefield. So right now I'm not at home. I'm out in one of the forts out here. I'm doing some work out here. But this is my first time joining. I just wanted to say hello right quick, and I'll turn it back over to you, Dave. Thanks, everyone.
Well, it sounds like you have an interesting technical programming background that would fit right in with
Actually,
the people here.
I'm not really a programmer, Dave. I'm a network guy, so ones and zeros as far as moving the packets around, around the network or battlefield, wherever I could make that happen.
Well, I will tell you, we have a network configuration that we use in our radio systems that confuses lots of amateurs, and but works really great once you get it set up.
Oh, wow. Okay.
So if you find what we're talking about interesting, please come back.
Okay. Yeah, sure. Thank you. I appreciate it. Thanks.
Yes. Next on the list, we Scott Newell, and I assume he's still mic muted. Yes. So after that, we have Rob Robinette.
Good evening, everyone. So I have, as usual, a list of things to talk about. I think, of course, we've been primary project or the underlying project is the antenna project, and I have to say we haven't really made any progress. Michael, I don't think we've provided you with any new antennas, and I don't know if Michael has done any surveying with the field probe to look at his site. But I think we had a dialogue with the members of the IA International Amateur Radio Union has a group looking at background noise levels, and it was interesting. We've been basically told that um, Glenn N6GN's active vertical dipole design, which shows superb common mode rejection, doesn't work. I love it when theory trumps experience. So that anyway, it's interesting. But what kind of what I came out of this dialogue with this, they have a committee that is trying to measure noise level across the spectrum around the world. And so, I would hopefully we could start contributing to that as we deploy the personal weather stations next year. We could contribute noise level data that would be of interest to them. But we kind of devolved into a battle of theories and no mention of experience. So anyway, we'll see. In any case, I think that what they're doing, the measurement of background noise, the way they're doing across the full spectrum, I think is extremely valuable, and I'm continue to want us, if only for our own purposes, to consider adding a new database of noise measurement data to what we record in the future. So that's a future a possibility for, I think, that could contribute to our radio science goals. Let's see. Well, as I've been listening to you guys, I've been working on, I've had a conversation with, I'm looking for lower alternatives to the B-Link. Not that the B-Link it's a great platform, but it is, it's a significant component in the cost. And Jim Lill, WA2ZKZ, who I've known for years, and uh, reminded me this week in dialogues that he has been using successfully the RX888 with the Orange Pi 5, and that the problems that I had seen in last year when I tried to use it were due to USB cables, not due to any problems in Linux or in the platform itself. I had my problems last year were that I would see glitches every few minutes, at kind of semi-random times, and that the communications between the 888 and Phil's Radio D software would be interrupted briefly. So Phil's experience, successful experience in several deployments. He's built, I think these are things that they developed for military use. His successful use of the 888 has stimulated me to investigate the use of the 888. So I'm of the Orange Pi, because you can buy a 4 GB Orange Pi for $85. And you add a $20 heatsink, it's of course you have to have a power supply and so on. So it's maybe something less than half the cost of a B-Link. So anyway, that's what I've been doing while I've been waiting for you. Is Bob Strickland, I don't think is with us tonight, sent me an Orange Pi that he had, and I ordered a heatsink, and I'm putting it together. And I hopefully will have a couple of 888s arrive tomorrow from China, and I will see if this new configuration works. So that could be an alternative to what we have configuration for what we've been talking about as part of the next year's deployment. Lower the cost, lower the size. I know that I measured the power consumption of an Orange Pi, and a 888 is about 15 watts, which is about almost half the power consumption of the B-Link plus a 888. So that's on my hardware development work right now.
Hey, Rob, what is the USB cable that works versus ones that don't?
I think they're shorter, but that isn't the only criteria. Is that Bill? Bill was going to send me a link to a vendor, a particular USB cable that he found that works. So I haven't. I think he forgot to send me that link. So I'll have to ping him on it. But that's an interesting possibility. Especially for those of us who are running multiple antennas, each with a 888 on it, it may not be necessary to have a B-Link on each one. You could lower your system cost and power consumption and size and everything. If the Orange Pi 5 has a octa-core, 8-core ARM CPU in it. It's double the number of cores of a Pi 5. Pi 5 barely is useful with a 888, but the Orange Pi worked really well last year, except for these problems with the intermittent connectivity. So that's another one. Anyway, the other area I've been working on is Whisper Daemon. For those of you who are running Whisper Daemon, not only is it uploading the grape data, but it's been uploading your Whisper and FT4 and FT8. This weekend, I worked a lot with Philip Gladstone. We found a bug in his uploader, which he fixed it, and he added support for Whisper uploads to his PSK reporter site. So I don't think I put that code up on. I haven't had a chance to go through, and maybe Michael, you might be able to help me with this. Is to go out to the Whisper Daemon sites and like Nathaniel's, and do a git pull and restart everything, including the PSK, the radio D. Restart everything, and it'll expand the amount of data that we're uploading. It's also the beadlink sites. If we can, I'm starting to run them at 128 megasamples, and added FT4 and FT8 uploading to PSK Reporter. And for those of you who are operators, you may have seen that today, 6 meters was wide open. I mean, all across the U.S., from the U.S. to Europe and everything. So if you had a site that was logging all of the 6 meter activity, you would have seen, I think this, those who know this better than I say that it's probably today was the best propagation day they've ever seen. So on especially because 6 meters was just the MUF was, I don't know, it was 42 megahertz over the U.S. It's really quite extraordinary. So anyway, I'll go back to my hardware building here, and we can talk about other things. But oh yes, I think Dave, you caught that modulation group meeting has been moved to next week. So
It seems to be a little conflict, yes, for tomorrow.
yes, I think there was a conflict with a big event happening tomorrow, so they decided to postpone it. I think Dave Schwartz, I don't think he joins us, but Dave Schwartz added 12 meters to the WWV beacon. So WWV0, WW0, that beacon, that whisper sound beacon is now transmitting on, I think that it has antennas for 7 bands now. So it's missing 17 and 6 meters are the only ones. And that beacon is the most heard beacon in the world, has the most spot reports. And after it is, I think, EBU. It might be yours. Nathaniel is the second most heard beacon out there. So anyway, that's all I can recall. I'll send it back to you, the net here.
Okay, well, I believe I've called on everybody. If there's anybody that didn't, oh, Jamal jumped in there. Jamal, do you want to say something? Mike? Microphone.
Hello, everyone.
Hello.
Hello, Dr. Dave. I just wanted to mention that Dr. Nathaniel and I has reached something good at our research, is that we were going to simulate an HF transmission from WWV at Colorado to Springbrook, and and finally we reached that at elevation angle of 8 degrees. The receiver finally received an HF signal that hits directly the receiver with some tolerances, and actually we reached that the total absorption is going to be 2.12 decibels, and this makes sense that the geometric path distance is greater than that of the effective distance on the Earth's ground. Yeah, I just wanted to share this. Thank
Very
you.
good. Well, at this point, we've gone through everybody, so we're open for general discussion.
We've made it through. It's 10 p.m.
Yes.
Well, I will say for my part, I have 2 antennas deployed here, the DX engineering antenna and a LZ1AQ variant, not the official. I'm still in the process of setting up the electronics on that. And I do have, as Rob mentioned earlier, one of Glenn's field probes. And I've tried to standardize the connection of those 2 antennas to a 888 and a computer so that they have a similar, exactly similar feed line. So the comparisons between those two, and actually I've done that for my 2 other antennas on the site for comparison, are a little bit more apples to apples. But regarding the specific mention Rob made, a program of using the field probe and then anything else that might be necessary to facilitate at my end from a configuration point of view, the comparison of these antennas, and then with some criteria for establishing a recommendation to the DAISY grant, I would appreciate some input on, in particular, the use of the field probe is something that I'm on a very steep level of the learning curve on. So that's I'm poised here, I think, with some, at least a space and some of the equipment, but a procedure which would effect and contribute in a informative way to the decision that we have before us, I think is one I need a little bit more guidance and information on.
I think is Rob, do you have any comments?
I'm sorry, Michael, I've been a little bit out of the loop on the antenna project, but I think that and we should have a session where we discuss the use of the field probe, and perhaps even with Glenn's involvement to kind of explain to us how you might use it. Uh, I found it incredibly informative. I've been, one of my side projects is I'm working on this beehive health monitoring projects that's using whisper transmissions on the ISM band, and 13 megahertz ISM band, to communicate the health, the temperature and such of beehives. And one of the ways I used it was I used the field probe to measure to see if I complied with the FCC regulations for emissions levels. And it's just wonderful to be able to take this thing out in the field, 30 meters away, and know, geez, I'm at 1/10 the maximum field intensity. So I've no problems. To 20 milliwatts on into a dipole works just fine, and I'm heard regularly by my 20 milliwatts into my dipole attached to the side of my townhouse is daily heard by the fellow from West Point. Has a K1HJ or something, has a receive site up at some missile silo north of West Point, which is one of 2 sites on the East Coast that receives me regularly on 13 megahertz. Whereas many others, and I know there are others listening because they're Whisper Demon sites that I've configured, don't hear me. So one of the interesting things I'm seeing from this is that if you look for low powers, if you have a low power beacon, it's kind of much easier to identify when you're getting single hop and double hop um, propagation. I mean, I can see every day during the daytime, I go 1,000 kilometers. There's somebody in LA. Clint picks me up in Utah. So I can just tell when the band's open, and I can tell when in the evening, interestingly, it's evening time, right at sunset, when the East Coast starts picking me up.
Yeah, but
So
Rob,
it's
we need to use this field probe to measure a site for a receive antenna.
yeah,
So, I mean, there's
it's it,
probably dozens of useful things for this,
it's
but
yeah, I
is
know
there,
that isn't the. I mean, the bottom line is to walk around and look for, and find a location and orientation that has the lowest noise across the spectrum. And from 0 from, well, at least from
0 to
3
30?
to 3 to 30. and your tiny SA will give you a pretty good view of it as you move around.
Right. But I think though the idea is, I suppose I can use it from a qualitative point of view and get a sense of things. But if what role is this going to play in the average deployment of one of these sites
Okay.
for the DAISY grant?
Well, I think that
If
yeah,
any, I mean, in
I
some respects, we could cut to the chase and simply say, I have cited the DX Engineering vertical mini whip at a point where it actually performs pretty well. It performs pretty well, and um, I have not yet cited an LZ1AQ variant in a position that rivals it. So far the DX Engineering between those two is winning. The DX Engineering does not exceed the receive capacity and the signal reports and so on of the T3FD that I have, a three-legged folded dipole, or a inverted L that I have on my site, but those aren't standard, and really they're not likely to be replicable deployments. A horizontal loop or a vertical loop with an LZ1AQ amp, the DX Engineering whip. So if the probe plays a role in how we do these, I'd like to hear how we can standardize a use of it that really assists us in overall deployment. Otherwise, another test might be for me to pack this antenna up and send it to another site and see how it behaves, just as a comparison. Or
I think have you walked your field with
yeah,
the phone, and if you found any significant variation as you move across the field and change the position on the field and the orientation of the field probe from vertical. In other words, can you see any significant change? Because you may have such a good sight that you don't see anything unless you get close to your house or your barn,
I have a pretty good site, and the main thing I'm dealing with on my site is a suspicion of some local noise, and where is it, and how can I mitigate it? Finding a place on my property where I can stick the antenna where that's it's far enough away from where I think the noise originates.
You
I can
should
do
give
that.
it, but the point of the field probe is for you to find that noise source. You should be able to, as you approach it, you should see the noise
Oh,
level go up.
I'm pretty confident I know where it is. I just don't know what it is. It's in my
Well,
shack, and it's probably it has something to do with power.
well,
But
well. Anyway, that you may not be a good site to use it, and of course, it may be too much to ask for.
Suspect wall
Ask
wart.
of what?
I'm
probably
saying to Michael, suspect wall warts.
that is my major. They're top on my differential
Yeah,
diagnosis.
I just found just on this
This
topic, and it's very apropos. I just found a wall wart that is a switching wall wart, but it has no input filtering whatsoever before the rectifier, and no bypass caps around the rectifier. And rectifiers on bypass can be great sources of DC to daylight noise. So pull wall warts and see which one makes the noise go away.
Yeah, I think that may well be more important. I can because I can see the noise. I don't, and I can get kind of close to it. I just don't know which wall wart it is. The concentration of them here in my shack is fairly
Yeah.
high.
Another
But
thing that's useful besides the that E-field probe is a little loop on the end of a piece of coax, which allows you to sniff around for things. It's a little more localized than a E-field probe would be.
And I have a couple of those, and that I intend to use and kind of connect to that tiny SA Ultra. And that is, I guess I love doing crap like this at my house, right? Looking around for stuff. How generalizable is it? I mean, some of this stuff is going to be so specific to my site. Um, what role is this really going to play in our decisions for a deployment for the grant? And really even in
Well,
providing a useful, generalizable set of instructions or advice to the average person who, one way or another, even outside the grant, is wanting to set up a site and contribute.
Well, I'll say every anecdote helps the next guy.
I don't
We're trying
disagree
to
with that at all.
in New England ARRL division, we actually have an RFI team of which I'm part. And when one of the teams finds an RFI source, the idea is to document it so that the next person can benefit from the experience.
Something like that would be great. And Dave Witten, Dave Larson, and I have talked about this in some respects, is especially if the spectrum display that we've been that we have a tantalizing sense is so useful with K9Q Web, and which a Kiwi can provide too. If you see it disappear, or you can see patterns in a 30 megahertz display or some subsection of it where you can say, look, this pattern is indicative of a noise like X or like Y or like Z. I remember a session where I was working with Clint, and he was able to recognize that the noise I was exhibiting at my site, which has now been fixed, was due to the fact that I had one residual box stuck in an outlet in my house, which was one of these Ethernet over power line boxes. And it was producing a characteristic kind of noise, one feature of which was very distinctive, namely, it was filtered for the ham bands. If you saw a ham band, the noise dropped down and you could see all these beautiful signals in a ham band, but then between the ham bands, there was these mountains of noise. And he recognized that that was a signature of something he'd seen before, which was these things. So being able to like take a screenshot of one of those spectrum displays and say, look, see how this is looking with these valleys here that are right where the ham bands are, because the FCC mandates that there be filtering and that they not cause any interference there. Make sure that either you or your neighbors nearby or something like that don't have these things, or if they do, you can come up with some alternative. But then there's other ones like the typical kinds of wall wart noise, or typical kinds of AC line noise, or other ones. But as everybody keeps pointing out, there are so many variables on these things that if we really commit to walking down that path, it can be hard to make a a package or have a set of instructions which really suit everybody.
I'll
In some
share.
respects, almost feel like cutting to the chase and say, we just know this antenna works pretty good in most circumstances, so let's send it out. And don't waste your time wandering around a yard with a bunch of things unless you want to.
So one question I have, so the field probe, that thing that's transmitting the signal and then you receive it with the antenna, or the other way
No,
around?
it's a
No,
receiver.
it's a receiver, sort of a standardized receiver with one of Glenn's amps right on the handle with a power supply, and the output of it you plug into a Tiny SA Ultra or Tiny
Right.
SA, a
So
signal analyzer. So
this can't really give us any information on active antennas anyway, can it?
No, this
No,
is
what
just
it's
for
intended to do is look for noise sources
find
that are
your
interfering with your antenna.
or find the best location on your property to place
put
your
the
antenna, and the orient and an optimal orientation for that antenna.
Okay.
And there are sites where those techniques have produced reduced the spectral noise just by finding a good location by 20 or 30 dB. It's actually now this may not be relevant for our for our installations because you know, they're already going to be pretty quiet, you know, so it may not
Right.
be even
Well,
necessary to do these kinds
It,
of ask
well,
people
you
to do
don't know
these.
where they're going to be sited. They could be out in a field, but they could also be in some suburban backyard.
Well, I thought that one of the criteria for selection for sites would be that they're reasonably quiet. I mean,
Yeah, but you have to determine that ahead of time.
well, here's
Yeah.
a way to measure it. That's
Right,
a kind of
exactly.
that was the point. The point of the field probe is here's a way to measure
Yeah,
the
it's an inexpensive way of doing it between the tiny SA, which is really a cool little instrument,
yeah,
and
it
this
is a it is
field antenna.
yeah.
That's
But
we
they
might
they are
even consider
cool.
having a pool that we could let people borrow to survey
Yeah.
their sites.
but okay. So yeah, I can
But
see
if
the
Michael hasn't figured out how to use it effectively at his site, then maybe it isn't a useful tool for others. So that's, you know, I'm not trying to mandate it in any
Yeah.
way. It's if it isn't useful, if it hasn't been useful for Michael, maybe it won't be
Mm.
for others in his
But
situation. So
by the way, referring to power line over, I mean Ethernet over power line, the original Radio Shack versions of that operated at 3.58 megahertz.
hmm.
They had to recall those.
Yes. Well, I think asking 25 people to take possession of and learn how to use a field probe and wander around and try to find it's probably asking too much unless during the course of this process we can come up with an algorithm to guide its use. And that's not just the use of the field probe, it's the use of the tiny ESA Ultra too. It's
Right.
not an entirely trivial instrument to use. It's got a pretty deep and complicated, menu tree and that kind of thing. So if somebody is not used to using it or experienced in using it, there's a steep learning curve there, and it's a pretty significant investment of time. So
Right.
from a practical
Well,
point of view, I think I kind of feel like there is a role for comparing antenna A and antenna B without paying attention to field probe use, and just sort of see under a couple of different circumstances whether one does better than the other on average. Um,
yeah,
Trying
we'll
to
also want,
tune and
especially if,
maximize and tweak its use on a given site is probably a little much when you want to do just sort of a rollout of a bunch of installations.
yeah, well, we're gonna at least need, if we give people, say, a loop option, or a dipole option for that, we're gonna have to at least give them some guidance as to orientation.
So, okay, so let's take a step back from it. The first question, the really important question right now is which antenna do we recommend for this particular project? And Michael, you have a few candidate options right now, right?
Correct. I'm testing two. One is, of course, the DX Engineering one that you wrote into the grant.
Right.
And it's performing well. I mean, I've got some bigger antennas, lots more wire in the air that I've had up for a while and I've tweaked that do better than it. But I've got a
Okay.
couple of antennas that do worse than it. So
Okay.
as far as I'm concerned, at my site, it's a middle of the road antenna, and if you look at it compared to not just my site, but compared to other sites, that is to say, if you look at how many spots it's collecting, it is,
Right.
in terms of raw spot collections, it does well
Okay.
compared to what's happening around the world in terms of whisper spots.
Okay.
And the traces I'm getting for WWV reception on that same antenna are also good looking from a
Right.
qualitative point of view, comparable to the traces I'm getting on other antennas at my site.
Right.
So the only hesitation I have in recommending that so the DX Engineering, is the fact that it is not a completely trivial installation. It's simple in some respects. I mean, you follow the instructions. You do need a ground rod to drive into the ground, and you need to supply the cable, and it has an F-type connector on each end that connects to the power injection that's in your shack. So there's a couple things that make it we supply we'd have to, if you were going to supply the whole thing, you might want to throw in the cost of, say, 100 feet of RG8 or whatever 75 ohm receiver cable with F connectors on the end
RG6
would be RG6, I beg your pardon, and a ground rod,
which is very doable.
And then the person on the other end has to assemble it, but
Now, one thing
that
about
would
it
be
is,
the only
I mean,
requirement.
but
I think it would work.
I've put those out. I've assembled multiple of those, and I don't think it's any more difficult than, putting wires up in the trees, or, I mean, it's very, and I don't even think that antenna will work without a ground, I believe.
The ground rod is the ground. There's nothing else.
it does
It's
need
just
something to work against.
it works against the ground rod shoved into the ground.
can
That's
work-
what it's mounted on.
The mag loop, where this is the mag. This is the active vertical you're talking about.
Right.
The active vertical
okay,
DX engineering. Yes.
Yeah. Okay. Right.
Yeah,
Yeah.
the mag loop wouldn't, but the vertical.
The mag
does.
loop doesn't need any ground. It's just right. It's a loop. It's balanced. It's
Right.
coax back to the
That's
shack.
why I was thinking the mag loop, but okay. Yeah. So
the other
active...
thing about the vertical is it is quite tall. It is an 8-foot element.
But
so that might be a problem for some people.
Yeah, but compared to what?
Well, like a loop, if that is a effective antenna, that might be.
The typical loops that are used
that...
with the LZ1AQ are 3 feet in diameter.
Right.
Yeah,
and
that's a 1 meter
they're pretty
loop.
effective.
So I've actually mine I increased to 1.3 meters.
So
and it made
I guess
a difference.
so. Right.
It's that size.
So you're trying two or three different ones.
I'm going to assemble a third, which is the original LZ1AQ from Bulgaria, which has various options. The one I have now is the one that Dave actually recommended, which was the K2 Charlie Yankee or N2 Charlie Yankee variant of it.
N4CY actually.
N4CY.
Right.
It has no options on it. It's really
just
you really
loop
just hook it up to a loop, right?
Yeah. There's another version of that I also have that I got from Ella Kits or Parts. Same design, or at least same root design. That's what's currently out on my stock.
And it seems to be performing well, but the one that I have here, the K2 and Charlie Yankee variant of it, does not perform as well as the DX Engineering at my site. Not very far behind, but doesn't it's I think it's a significant difference.
So
how do you have it oriented?
So okay. So the
upright.
Answer, for the antenna committee's task right now, the main goal is just to recommend an antenna that's effective, that we can easily distribute to grant stations. And I guess by effective, we want to make sure that it has an appropriate pattern. It can receive, it has an appropriate sensitivity. And I think those are the main things. We want to make sure that it's going to be relatively easy for someone who receives it to deploy in terms of instructions and support. That's going to be rugged over the course of the grant. And I think the other thing that struck me when I watched Wayne Griffith's presentation the other day was he pointed out that if you have a horizontal wire antenna like I have at my house, you really get these ground reflections. I don't think we want that in the antennas that we send out.
That and a complex pattern.
Right, that and a complex pattern. And I think that either one of these active verticals or these loops is probably going to be the sweet spot where you don't get those ground reflections. You get a relatively a relatively simple pattern to understand. It has relatively flat performance across multiple bands, from 0 to 30 megahertz, or 1 to 30 megahertz. I, so I, I think it'll be relatively simple to ship, deploy, and I think it will work.
Yeah, I'm trying to
No.
talk to Michael on this. Michael, I'm trying to figure the plane of the loop. Which way do you have it oriented? Did you think about?
It's vertical, and what I've been toying with locally is to orient it to a position which nulls the local noise.
Right,
But
but you also have to
when
be
it's
cognizant of what direction WWV is.
correct,
You want it close to being in the plane, and then, perpendicular to the plane is your null toward noise.
well, here's one question I have: why not orient it horizontally?
I'm not sure how
Which
that
is
would be.
omnidirectional. It's a horizontal loop which is omnidirectional.
Yeah,
and
for
would
a
probably
vertically
be
polarized signal, that could work.
That's what I was thinking. And I have a local noise issue that I have to, I can probably fix it because the noise is not that large in terms of overall power. If I put the antenna far enough away, it's going to be minimized. And if I do a one-to-one comparison between a vertical and a horizontal loop, I think in that respect, what I'm
Yeah.
really comparing are two different antennas, both of which are omnidirectional, both of which are not going to have complex lobes, both of which are easy to deploy, and both of which are relatively small footprint, because we're talking about a 1 or 1.3 or 1.5 meter loop, horizontal. The putting it vertical is useful if you need to null something, but if you really want it omnidirectional, I would say put it horizontal.
Here are all of your antennas ranked by
Right.
by the last
So
24 hours.
So B2 is a 200-foot long, three-legged terminated folded dipole. LN is about 80, it's probably say about 40 meters of wire in an inverted L. And FB is the DX engineering vertical mini whip, and B1 is the LZ1AQ loop, which right now is not oriented horizontally, is oriented vertically, primarily to minimize, to provide a null pointing in the direction where the local noise, that is within 50 meters of where the antenna is maximum. So it's not oriented to point maximally toward WWV or anywhere else.
And you've ensured
and
that
it's
all
not lying flat.
And you've ensured that all of these receivers have roughly the same input signal level and frequency characteristics, so that we're not one of them isn't suffering from overload or something like that.
No, they appear to be behaving pretty comparably. With whatever variations there are in the length of the feed line, what's happening when they get into my shack is that they're served by the same turn island systems, shelving filter and preamp.
Okay.
And
so
then
they'll have the same shelving and gain.
the same thing, right?
Yeah. Well,
Except the
yeah.
active antennas, those are two active antennas that we're comparing, though. The LZ1AQ is an active antenna. It's got an amplifier out there, and so does the DX engineering. The other ones
well,
don't.
these two, the
B2 and the LN, B2 and LN are not active. They're just wire.
Yeah, but the other ones, well, they're wires going in, but they have a they have a preamp in the shack, right?
Correct. All four
Okay.
have a preamp in the shack,
Okay.
but
Okay.
the active
Okay.
antennas have a.
Okay. Well, I mean, as you can see from this, the DX engineering, of course, goes wins down on the low frequencies. I mean,
Yep.
you can see here on 80 meters, it's got 50% more spots. Now this part is that there's two ways of this is kind of how I evaluate the performance of different antennas at KFS and KPH and elsewhere. Is there's two ways to evaluate them. One is the number of raw spots. Okay, how many reports did it post up? Okay, and the other one is how many different different beacons did it hear? And this page uh, it only shows the raw spot counts in the raw column. So you can see that there's not a tremendous difference in the total number of spots that are received, nor are there for most of these, for these three antennas, there are 1,800 different beacons that were heard over 24 hours. So this is, so Phil has, Barnard, who has created a script that allows you to quantify the difference in the number of received spots recorded. And I think that for our purposes, that the antenna, a better antenna is a better, not the one that necessarily got the most different beacons, but the one who heard heard the most transmissions, i.e., the raw spots that it recorded. And I mean, from what from this survey, you can see even here on 17 meters. I mean, on 17 meters and 15 meters. The D engineering looks like a pretty decent antenna up through even through 10 meters. All of these numbers, even
I
though
agree.
that the green boxes are the ones that have the winner in that on that band. But if you look at the winner on 40 meters, the difference in the number of beacons it heard, 220, versus that of your best antenna is, well, that's not trivial. It's over 10% more. I'm not sure that's as meaningful as the number of spot differences. But those on 40 and 30, your DX engineering doesn't do as well. But once you get to 20 meters, geez, it's pretty close. Here it's the best. There's, anyway, this, if you wanted to say, if these antennas are near each other, are you locating them physically? Well, you can't do that with the big long wires, but for the for your DX engineering and the LX, are they near to each other in the same?
Yes.
Okay, good. Because
Yeah.
they shouldn't interact. I mean, you could have them within a few feet of each other, and they probably would not affect each other. So so I think that'd be one of the things that Glenn would suggest is put your antennas as close together as you can, or this class of antenna, put them as close together so that they're both exposed to the same noise fields.
Well, you do have to worry about coupling between them.
I've been through this argument, and it turns out they don't couple the way you think they do. And I don't think I don't think in this test they're likely to couple with each other. Um, the but but in any case, put them someplace generally near each other. I mean, it's if you put one at one end of the field and another at the other end, it seems like you're not working under the same. They're not being exposed to the same fields. But anyway, I think your impression, Michael, that the DX engineering is proving to be a good choice, I think is true. I think it's I don't know
I
about
think it's a serviceable antenna. I think it will work. I
yeah.
think I could tweak an LZ1AQ and probably get its performance improved. Would it exceed this or not? That remains to be seen. But
Yeah.
if you were going to deploy this DX engineering antenna, I think you would get good results.
I think that's a nice thing to hear, because that is what we said we would use. And
yeah,
it makes it
now
I mean, the DX engineering has a great supply chain, so it's very easy to order from them and work with them.
Yeah, so
now the only other word I would be really appreciate hearing would be for someone like Gwyn who looks at these things all the time to subject his expertise on analysis and kind of see if, is there anything about this is worrisome? Is there anything about it that's going to, you know, provide a
Well, that
problem that
well,
we have to deal with? But, you know, I think when I look at some of the Grafana web pages and look at the noise profiles and look at the signal to noise ratio and so on, the DX engineering antenna looks like it works fine. Is it the best antenna you can make? No. But is it a piece of crap antenna? No. Yeah. And
yeah.
is it something that people can assemble pretty reliably if they have a little bit of skill doing this? The answer is yes. So
I really like that. I mean, the less things that we have to support directly, I think the better.
I
And
agree. Yeah.
I think, you know, again, with the DX engineering, you know, not only do they have a supply chain, they have a phone number. You can call them up, you can get support, they'll stand behind it. You know,
Now,
they've got all that in place.
Yeah.
yes.
somewhere
And then we
about
don't
4
have
to
to do
6
that.
weeks ago, we started this discussion, and there was a lot of questions or issues about some of the preamplifier circuits, and I don't recall which antenna that was in. There's a lot of comments about the 3-terminal regulators weren't bypassed, the things would go into oscillation, and oh, that was a terrible design.
That was a different DX engineering
Okay,
antenna.
that's a okay. Never mind then. Forget
But
I said that.
I
That's
did
fine.
I did express some skepticism about DX engineering's engineering expertise, to be honest. But if Michael isn't experiencing problems, and you would see the oscillation problem, Michael, would show up as a you'd have a picket fence from 100 kilohertz up, and you're not seeing that on your K9Q spectrum display.
Oh no. I mean,
Yeah,
let me
yeah.
see. Let me see if I can share a screen here of the DX Engineering Kiwi screen. Let me refresh this. Give me just a second, but it looks like a good Kiwi site. I have, all right, let me get Zoom here and let me share, and I'm going to share.
Michael,
Am I sharing?
I remember that you noticed, or you mentioned that one of your antennas you said requires a ground rod or an earth ground connection.
DX Engineering, the vertical, you mount it. What DX Engineering ships you is a back plane, the box that attaches to the back plane, 2 sets of U-bolts, one that's going to connect to the aluminum antenna, and the other connects to a copper ground rod that you drive into the ground. That's what mounts the antenna.
Well, so if these antennas are sited close to the a VLF active antenna, if the feed line or the feed line ground coming from the shack isn't actually isolated from the ground rod, then what could happen is that it could dump mains hum and hash that's picked up from the shack. It could dump it into the local ground, and it could introduce noise into the front end of the VLF active antenna, because I had this problem in the past with when Nathaniel and I originally ran the conduit and the cable. There were recommendations to put in a ground cable from between the site and the shack, and what that did was that completely broke the isolation that was that I had added onto the VLF active antenna, because the reason why that the VLF active antenna and the VLF system is so sensitive to this is because these are obviously lower frequency components, and they get their source obviously from the shack, where there's house wiring, there's all sorts of low frequency interference that can get transported to the site. And just like this antenna, the VLF active antenna, its other terminal, where it's actually getting its voltage from, its signal voltage, would be one of the terminal is an earth ground connection. And that's why that it may not be possible to site these and the VLF active antenna with this if it's not isolated, meaning that that hash could be transported from the shack to the local site.
Well, I mean, we have our one-to-one isolation transformers that will give you 80 dB of isolation before below 1 megahertz. So I don't.
Yeah,
Am
but
I sharing this
put,
screen?
You don't
Yeah.
put that between the bias T and the antenna.
That's the problem, is that you have a bias T on this thing.
But it is possible that we could come up with chokes that would be effective down to VLF, though that's hard.
I do think that the DX Engineering has an option of providing a separate DC ground power feed out to the antenna, so you can
That
run
is
the
true.
Yes,
DC
it
line
does.
separately, and then you can apply all kinds of choking and filtering on that line to suppress any of the even the LF and
Yeah, that's a
and
good
below.
point, Rob.
You can use core comms. You buy those core comms things that go into power
Right.
supplies. They're very good at suppressing low frequency EMI. So it's pretty, but it's a good point. I mean, Jonathan is absolutely right that this antenna and any unbalanced antenna, monopole kind of antenna like the DX Engineering, does introduce a ground loop. There's inevitably a ground. You have a ground out there that's at the antenna, and you have the one in your shack, and you really don't want any of the RF or from the shack carried out to the antenna. So you're right. But I think that there are ways to address it with the DX Engineering.
Yeah, I think you're right on that. And by the way, I don't know if how far down the DX Engineering one goes, but it is possible to design these to go down into VLF as well as HF.
I think yeah, I think
they can be very broadband.
I think they talk 10 kilohertz.
Yeah, so they actually are.
As I recall, the specification was 10 kilohertz to 30 megahertz or something. So it's
Am I sharing the screen?
Yes, yeah, we're looking at your Kiwi screen,
Okay.
and I do see some peaks. You have looks like 5 dB peaks up at 24, 25 megahertz and 27. And then you got the 27 megahertz leaking through from the
Right.
RX 888. But that's not a big deal. But you can see
And then you have medium wave down here. And there's some electrical storms and lightning, so this is what some of this business is.
You got some big lightning flashes there that are going across the. I don't see.
It's this low frequencies. You see these sort of weird bands across here.
Yeah.
Low in. That's what I've been trying to null out. I don't know why it stopped all of a sudden, but anyway, it's a fairly. I'm outside of town. I'm not near a whole bunch of stuff. There's a few desultory homesteads around, but this doesn't look too bad. The noise
What
floor is
yeah,
down here.
click your tune to that right above 25 megahertz. Move your
I
tune.
click down here, I'm at
Yeah,
81. We're at 25.
in that gap where it's low there. See what you're seeing. So you have that's pretty darn hot. Yeah, you've got the noise floor of the Kiwi is minus 115, and so you're 30 dB above the noise floor of the Kiwi. That's I mean, that seems like more gain at the on the DX engineering than you need, and it might result in overloading. So I think you got to switch on the DX engineering to adjust its gain, right? They allow you to adjust the gain
Yes,
a little bit.
there's three options. There's minus 6 dB, there's 0 dB, and there's plus 6 dB.
Yeah, well, from what I see here, now it's evening,
It
so
is
you would
evening.
think, and you would
Things are
think
noisier around here.
I think that I would, well, I think that at 30 megahertz though, I think 10 meters is closed, right? So you're not looking at ionospherically propagated noise up there. You're looking at noise that's generated by the DX Engineering's JFET. And I think so I would reduce that. I would turn it all the way down. It's unnecessarily there's too much gain out there. If
Well, I
they,
could put it on 0. Right now it's on plus 6.
I'd turn it down by
Default is default
0.
is minus 6.
I'd
And the
put
way
it
it
in.
was looking before we increased it. This is the sort of thing I guess could be the subject of site to site adjustment.
Well, my understanding of this is that at night, at 30 megahertz, you should see the Kiwi in the lower right hand corner should be reporting about minus 105, minus 110 to minus 105. And that means that the noise coming from the antenna, and at that time of day it should be the amplifier out at the antenna, is the source of the is your determining your noise figure. And if you have more gain out at the antenna than that, then all you're doing is you're just moving the whole range, dynamic range up and bumping it against the Kiwi's overload. And you're gaining nothing in terms of signal sensitivity.
Well, you're not going to override the receiver's noise if you go anything less than the 6 dB.
No. You're what you're seeing is right now you're seeing noise from the you're seeing all that noise at 30 megahertz, right? I presume 10 meters is close. I don't see signals there. So if you look at the dip there up at 28 megahertz.
Now I've just switched. Do you see that I've switched?
You switched to something.
This is the LZ1AQ.
Well,
on the same site.
Yeah.
The noise floor is a little bit lower
Yeah.
up here. So I go down here just above it's 92. It's not too dissimilar.
Yeah.
You see a little more prominent this noise down here in the 2 to 4 and then roughly around 5 megahertz, this chop in here. But otherwise it looks fairly similar. Right here, the noise floor is.
You hit the auto scale button there, so it looks like your peak signals are somewhere in the minus 30. That signal right below 10 megahertz is probably what the key was using to, or that one. That's a very strong one in the 7 megahertz broadcast band. Yeah, that guy. He's probably it. But my point is that if you're seeing when the band's closed, if you're Kiwi and the 888, you can get the same numbers off the 888. They're slightly different, but if you're seeing more than minus 105, then you're just driving the Kiwi too hard. It's not, you're not improving your sensitivity of your system. You're just making it more likely you're going to overload the Kiwi. The Kiwi doesn't have RFAGC. So if you drive it too hard, the signal coming in, it'll just full scale, go to full scale on the ADC input. Now the 888's different, right? Phil manages the um, the manages the RF gain in the 888, and you can, he can vary the gain by 80, I don't know, 60 dB. But on the but it has the similar situation is it's not good to overdrive it. In fact, if you reduce the noise figure of the 888 if you give it too much signal. So you won't overdrive.
Well, one of the things that was interesting was that between those two antennas at this site, the noise floor was very comparable.
Well, they're 10 dB difference. They're giving you 10 dB. You had minus 85 off the DX Engineering and minus 95 off of the LZ1.
Yeah.
So that's 10 dB difference. That's not a trivial difference. I think that difference only reflects different amount of gain in each of each of those. Now, we don't know. There's no schematic for the DX Engineering, but not that we necessarily need one. But what I saw there is I think you actually should. I would turn the gain down by 12 dB on the DX Engineering, and take a look, run it for 24 hours and compare against the LZ1. I think you might see a little better performance out of the DX Engineering, if only because it's not as overloading as often. That'd be the major difference.
Well, this brings up a point though. So, if we were going to guide people on how to deploy this antenna and how to maximize its usefulness, this is exactly the sort of, a set of parameters that we would need to develop in a nice, simple way to be able to guide people on how to, switch these jumpers. But
yeah. I mean, because you have the Kiwi, and I know the Kiwi so well. Okay, I can tell you exactly what's going on in your network because the Kiwi, I tell you, click it on 29 megahertz, set it to AM bandwidth, which means, look at the dBm noise level and subtract 40 dB from it, and that gives you the noise floor at that frequency of 1 hertz. So, when you, but we don't really, because we don't know the antenna factor of the DX Engineering. I don't think I don't think they specify it. So it's hard to really, know what the strength of the E field is and relative, what from what we're measuring. But in my experience, and I'm managing, it seems like 100 sites now. I mean, I've got these people, I'm logging on to people all over the world all the time, and I take a look at them. Many of them are Kiwis, and the Kiwis, I can tell when somebody has a problem, and very consistently, if the 30 megahertz AM bandwidth closed band noise level is above 105, you're likely to see overloading during the at some periods during the day, and that's unnecessary. Unnecessary sensitivity, oversensitivity for the Kiwi, and poorer noise figure on the 888 as a result. So the 888 won't overload. But it won't. You actually reduce the noise figure of the RX 888 if you drive it too hard. So.
Okay. Well, anyway, this is we've consumed a lot of time with this. I
hope it's
I hope one of the outcomes of it though is that this DX Engineering antenna I think is a strong candidate.
I agree.
I think there's some more work to be done with say a horizontal loop, which would come with a different antenna design, at least come as close to a one-to-one comparison with it as possible, given its omnidirectional characteristics. So a little bit more work needs to be done on that. And then we probably need to come up with whatever antenna we have, a way of guiding people along the lines that Rob is just kind of walking through, to optimize the reception at a given site using some mechanism. If it,
Yeah.
Dave, I know Dave Witten is working on an alternative or some enhancements to the K9Q web, so that if we can turn the spectrum display of K9Q web or modify it somehow so it's at least somewhat comparable to what you see if in a Kiwi, that we can use it as a guideline to make adjustments like you're suggesting, Rob.
Yeah.
For the DX engineering, there's 3 settings: +6, 0, and -6. So if we had a way to make a recommendation at any given site for the adjustment of those 3 options, that would be good.
Yeah. Well, the thing that the K9, one of the many things the K9Q web doesn't have, but the one that I miss the most is just the signal level S meter display. You don't know what there's
No, you don't know.
you don't really know what your what the signal levels are. There's some very hard to read numbers in the y-axis, labels
Oh,
on
they
the
change
y-axis,
all the time. They
but
bounce up and down.
they bounce up
And
and down, and I
yeah,
don't know what they mean.
no.
So I think that if you don't have that, it's really will be very hard to evaluate whether a site is working well. If we don't have something like the Kiwi, we won't really be able to tell people what their site looks like. And we have access. I mean, we have remote access to their K9Q web. We can log on, like, I could log on to your K9Q web,
Hmm.
and through the remote access channel, and look at your K9Q. If we could help people by having the K9Q web be just a little enhanced, you know, so that it would print out some dBm number, set it just the way the Kiwi does. Set it to AM bandwidth, and read out the power in that spectrum. Now, Phil provides so much more information about background noise levels. I mean, he provides a single noise um, number, and I think, Phil, that your number that you report in your control program is the lowest noise across the whole spectrum from 0 to 30, or is it
Oh, no, no, no. That's so good.
In the channel? It's in the
In the
channel, right?
vicinity of the center frequency. I use
Yeah.
arbitrarily plus or minus half the sample rate, but that could be more
Okay.
than that.
So
Or
it
less.
says when you put it in the signal, it's hard to tell which of those things that you label in your control program in that box, which of them are the whole spectrum of values, settings, and values, and others are relate to the channel characteristics. So
Good
that
point.
was my.
Good point.
So it would be nice if the 2 of them were somehow, it was identified. What is this number that I control prints out? Does it describe the signal in the channel, or is it in the 0 to 30 megahertz spectrum?
That's a good point. I thought about that myself.
Yeah.
I mean, I put them in a different box, but it might make more sense just to
You got that
highlight
box.
something
You
else.
had that channel box in the to the right of it, of the signals.
Signal box, yeah.
And you moved those numbers out of there, and I thought that was a more that box
Well,
to
I
the right
tried
was
to
a more.
move, I wanted to move all the numbers that change that are being measured into the signal box. The idea is that this is like the entries on a link budget spreadsheet.
Uh-huh.
Many direct entries
Okay.
on link
Well,
spreadsheets.
okay.
So
Well,
everything
anyway.
after gain offset from baseband on down is the per channel signal, including N0. Everything above that is at the input.
Let's see. Here, let me share one with you. I just have
Well,
this up.
I'm
Yeah.
reading it off. I mean,
I know you are. I want to see
Yeah.
it, and while you're, and maybe others would want to see it. This is
the numbers
this
under
is
linear demodulator are settings that you
okay.
can.
So those are settings. This is the signal box. The one we're talking, the number in the signal box.
are currently updated measurements. Top
Well,
half apply to.
RF gain isn't a measurement. It's a automatic setting.
Well, it's a measurement of what the AGC is doing.
Yeah. Okay. It's a gain
Show,
offset.
show it. I mean, look, I wrote this. I'll tell you what it means.
Oh yeah, that's why I'm asking you right now. So okay, so NO here tells your NO value is
N0 is for the channel that you're on.
that's
And
the channel. That's
the
the
bins,
kind
the
of
energies in the bins that are looked at are averaged with a very long time constant of something like 15 seconds, I think. That's because they're noise, right? And then at any given time, I find the bin that has the lowest average power in it.
Okay, so I mean this site. This is in Australia that we're looking at. He needs. I can tell him right now. I told him, your signal input level now it varies.
You're not sharing a screen, so
Oh, I'm not.
No, not anymore.
Geez, Zoom tells me I'm sharing a screen
Were,
that
and then
shows.
now you're not. Well,
I can see it.
I'm seeing it.
Really? Oh, wait a minute. Oh, I see. I got to select the right tab here. Ah, okay. Never mind.
Okay.
Okay, here we go.
So I mean, if we will have access to this information. We can remotely access this information at a site, at one of the personal weather station sites when they're doing an installation. So this is Jerry down in Australia, and his site, he just brought this up, and he has almost no antenna, so he knows that. But I could tell him immediately. I looked at, and I could tell him that, of course, because I can say the input level is minus 45. Well, it ought to be more like minus 30. I don't know, if it's daytime over there, so it ought to be minus 30. So he needs a good 15 dB of gain, LNA gain, and well, look at this. His RF gain is set for 26. Why is he? He probably has no. He needs a shelving filter or an AM blocking filter. He's probably the RF gain is being set by at that level, or well, I don't know. I don't know why it's so high. I guess.
Well, because the AD level is low. You already said his input level is low. Well, the RF gain is going up to compensate for it, and that's the maximum. It's the highest it can go.
Yeah.
But the ADD is still at minus 20, which is below the AGC threshold.
Yeah, well, I think that's your target, is right. The ADD wants to be in this. We've decided
that's
minus 20
exactly
is about
why. I mean, it's doing exactly what it's supposed to do.
Yeah, so it's your RF gain seems to work really well. I mean, you can see
Baseband and everything below that is per channel. It's the output of
okay, so everything below below A to D
baseband on down is all per channel.
Baseband on is per channel. Okay.
Yes, so that's the output of the filter that's tuned at 140956 at the moment.
Okay. So this is, of course, so that it looks like you take the baseband as the power across the whole channel, right?
That's right.
And then the N0 is translate that into 1 hertz.
Well, N0 by definition is per hertz. It has
per hertz.
dB millijoules or dBm per hertz. Same thing.
Yeah. But basically, there's a direct correlation between the baseband value and the N0 value.
Well, obviously, yeah. I mean, baseband value obviously has to be higher than N0.
It's going to be because it covers the whole of the spectrum. But right. Okay. Well,
at the very least, it's going to be higher by the bandwidth of the. See where it says NBW, that's noise bandwidth of the filter, 26 dB hertz. So at the very least, even if it were just noise, the baseband would be 26 dB above N0.
Yeah.
On average.
Okay. The NF, the noise figure is NF is what is that?
The noise temp and noise figure are computed directly from N0.
Okay. Oh, so that's 40 minus 133 minus 40 gets you minus 173
And
KTB.
reflected to the antenna terminal, assuming
Yeah,
the
yeah.
gains are all
Assume,
accurate.
yeah, assuming. Okay. Well, that's good. I didn't know that. Well, in any case, for the larger group, this page is available to Whisper Demon Grape users, and these numbers here are what we would use to advise um, a site remotely. We'd be able to advise them about the quality of their antenna system, some indication of the quality. This doesn't give us the whole spectrum view the way we would like it to, like we get with the Kiwi. But it does give us, I found this this signal box of yours very informative. Now, as I learned more about it, I think it's very.
Um, uh, can I ask that you say it doesn't give us the whole spectrum view, um, like the Kiwi, but you mean that we just aren't looking at the spectrum at this distance?
We're not. This doesn't give us across
Looking
from
at the whole
0 to 30.
spectrum is expensive, Rob. So, you do it only if you need to.
Yeah, yeah. That's
Even
no.
even computing this stuff when you're not looking at it costs a little bit when you multiply
No, I'm not saying that you should do any more than you're doing. In fact, I think you're doing everything we could want. If we look at if we want to
Rob, I have
look
a
at
question. I have a
yeah.
question though. You recommended that on the DX engineering, I should cut back the gain. Can you log in and share, or should I share this same screen?
Yeah, that's good. Good. Yeah. Let's see.
One question,
WDR.
Rob. One quick before you go off the screen, could you please, when you set up Whisper Demon sites, put a descriptive phrase into the config file? So we see where it says RX888 Whisper Demon. That's taken out of the description in the config file. It's meant for the antenna of the site. So put in something like the type of antenna at the call sign is the convention I use. That way we'll know what we're looking at when we look at one of these screens.
Oh, I
We'll
see.
know whose antenna we're looking
You have to go in and modify this. I do that actually. I've established a convention with Philip Gladstone that you can describe the antenna configuration on the same line as where you define the receiver to Whisper Demon.
Okay.
And at the end, and I have communicated that and put it into what the PSK reporter report. So if you go to your PSK reporter now, Phil, and look at your spots on his map, you'll see your antenna. If you've, I don't know if you're
I noticed. I just when you send me one of these screenshots, I don't know what I'm looking at. It's totally generic. I mean, I can look down and say, "Oh, VP0GB. I guess that must be him." Okay, but putting an antenna description in would be helpful. That's all.
Okay. Well, I'm modifying other parts of your config file so I can add the antenna description. Okay, I'll put it on my to-do list. Thank you. But usually in this case, for example, Phil, if you look at the title bar of this, it says Whisper Demon at VP0GB. That's the host here. This is the guy who.
Well, look, all I'm saying is I put in that description line for this purpose, and please.
Okay. Okay, well, let me get off of his site. Hold on a second.
And go to Firebat or AC0GFB or whatever.
Oh, do you know what it's?
If you do SSR Firebat, it'll connect.
Fire.
BAT.
Yeah. Okay. So this is. Let's see. I haven't been there. Okay, let's see if we look here. Okay, there's you, AC0 Firebat. So
and the input is 24
minus 24, which means
25.
you see that Phil has turned down the gain from the kind of optimal 20 to 25 has turned it down to 7.5 dB. So if you were to reduce the range. So yeah, to keep the A to D in range, and A to D is at minus 19. It's even a dB high. So if you were to reduce the gain out at the antenna by 12
But look
dB,
at the noise. Look at N0.
Well,
That's minus 122.
Yeah,
I mean,
well,
isn't that where it's supposed to be?
it would be no, it would be 12 dB lower. I mean, you don't know what that means.
Right.
That's
That's
what's
at the receiver terminal. I
that's
don't
at
know
the
anything
receiver
about
terminal.
what's
It
ahead of
doesn't
it. Yeah.
doesn't tell
Okay.
you. It doesn't tell you what the atmospheric noise is. This is only telling you what it's getting. And because you have so
Well,
much
I
gain out
also
of
I
the amp,
don't know what noise is coming from any preamp. Okay.
yeah,
Well, I
yeah. There's
say
no.
this is referred to the receiver terminal. I don't know what's ahead of it.
Yes,
Mhm.
and there is a place to put that into the Whisper Demon configuration file. You can put in the antenna factor adjustments so that the noise levels reported by Whisper Demon
Yeah, but they
are,
won't show up in the signal block. That's all. Just
but they're
remember.
not going to show up in your signal block, no.
Right.
So, but you can see from this already that the signal levels are so high here, minus 26, that the gain has been turned way down. It's to get
Well,
it
there's still some gain,
it's
but yeah.
yeah, there's well, it's turned down from the at it when the RF gain. I mean, if you look at the spec of I forget the part number, but if you look at this, I think Clint has done this
2208.
evaluation. Yeah, no, that's the A to D.
Oh, yeah.
It's the RF amplifier. I don't know if Clint is still with us, but he's written this all up on his blog page. And the if you Phil, if our radio D turns down the gain below 20 dB plus D 20 dB of gain, the noise figure inside the RX gets worse.
Yeah, but
So,
if there's a gain on the front of that, it's got a better noise figure. That's the one that will dominate.
well, it's
It's
again,
not
it
bad. You got to work out the system
you
noise
gotta,
figure.
the system noise figure is a function of of change.
If the preamp he's using externally has a better noise figure than the one in the 888, then everything's fine.
It almost certainly does, so that I think that's why we use external preamps is that they
Right.
have, but and of course you want to have the gain shaped. You want to shape the
That's
gain
the
across
important thing.
frequency,
Yeah.
and
That's the one that I
so
can't do.
so you can't do that. It needs to be done ahead of the. That's why I think we need to
Has to be done analog.
specify something like Paul's RF, shelving filter and gain
I
block.
think that's the number one lesson we've learned from all these broadband receivers is you got to shape the input spectrum.
Yes, if you don't shape the input spectrum, then
Yeah,
then
it'll work. It just won't work as well.
Well, you either get overloads, a lot of overloading, or the systems are, and in most cases, what I see is that the systems are deaf above 10 megahertz, relatively deaf. People go in
Because
and
they're
say, oh,
spending so much,
the
right.
Kiwi is a whole lot worse than my ICOM 7300 or something else. Well, they're different kind of receivers. You gotta, you're not comparing apples to oranges. You got to shape the RF going into a broadband direct conversion
So
receiver.
in this case, with this radio, with the preamp, the three settings on the DX engineering, if I decrease the gain out at the antenna by 6 dB, then that 21.8 that we're currently looking at would go to, 28
It would
or
go to
close
it
to
would go
30.
to
The
it would
gain
go
would
to
go up by 6.
yeah, and then the RF gain would go up to 15 dB.
And
And
so
if you turn the gain out at the DX engineering, if you turn it down to minus 6, then the signal levels would go down by 12 dB, so it would be down at minus 34.
34.
But it won't necessarily help your noise level is the point.
It's gonna all you're trying to do is minimize the overloading, and
overloading is not a problem. If it becomes a problem, you can start attenuating.
Yeah, I mean, that's the beauty of
you got to do the cascaded noise figure calculation. You know how to do that, right?
Yes, of course. Well, Glenn has a whole equation and schematic on how you come up with it, or maybe you did this. One of you, it's a It's not a big difference, but it's unnecessary. You have unnecessarily too much gain out at the antenna. The only advantage of having the gain out at the antenna now, and maybe now I'm thinking aloud, is that any noise introduced, common mode noise introduced in the transmission system from the antenna will be if you reduce the gain out at the antenna, that noise stays the same level, so the ingress of the RFI gets worse. So your signal to noise so in a sense there's multiple variables here in the and how to optimize the configuration. You may be fine the way you are. It might even be optimal, Michael. Now that I think about the background noise level issue, uh, it may be better to be driving the 888 hard and have it turn down its RF gain, because when the RF gain, the 888 gain goes down, it turns down the RFI levels as well as the signal levels. I don't know. Maybe it.
On
I
the
don't.
line, yeah.
I don't know. What is your?
Well, this is exactly this is exactly the kind of exercise we need to go through to figure out how we're going to advise people.
Don't have to guess.
Now,
It's all well understood, geez.
if we do it, if we're doing it with the same antenna and the same amplifier out at the antenna and the same shelving filter and line amplifier, the turn on system, I mean, then
Well, you're going to have the only variables you're going to have are, it seems like, is the gain out at the antenna,
you can change that to three different settings, and that's
three
it.
different services. It doesn't sound like that's it make a big difference. And in fact, I think as I thought through it, maybe you are at the best setting, because you may improve the signal noise ratio from local ingress of noise, from ground loop
Right.
introduced things. But that's good. I don't know. What is your what is your K9Q web spectra look like? Let's see what I could bring that up, but I don't remember what's your remote access number on this thing? Do you know? Let's see here. Hold on.
Well, Firebat. What do you,
No,
when
it's
you logged in?
it's a VD
Sorry,
here. Yeah, let me just
I can't remember what the
VD.
number is.
I can see it right here.
If you
You
do
see
VIC,
let's see, where is it? Here, localhost. I can see I can see the K9Q
okay,
web app
there you go.
on
Yeah,
my browser when I'm connected to you. So if I go over here and let's look at what your spectrum looks like. And now you showed
I
us,
did show it. I
you,
showed
sh-
the Kiwi
you showed the
read
keyways. So here,
Yeah,
I'm going to stop sharing this terminal
and
with you.
that's just a simple T connector connecting,
Yeah, okay, but that
going one
isn't.
way to the Kiwi and one way to the 888.
Oh, wait a second. Something turned itself off. My screens have gone blank. Okay. Now, I share screen. And here is, yeah, I think this is your K9Q web, looking at your 888. Now, this is, this is where I hope somebody can help us improve this, but doesn't look so different from the Kiwi map. I'm trying to find the color scheme this one I think is the most informative. And if I go and tune up here, well, that's 31. Let's pick it 28. I don't know. I see. There's no way I can't get a signal level here that's comparable to what
No,
we were getting out of the. But
no.
there's, so the scales on the left don't mean anything to me. I don't know what the scales mean.
Big
But
spike at 30 megahertz.
well,
Big spike at 30. Mike?
What's that?
It could be 10 megahertz in my system.
Oh,
I mean,
Yeah.
third harmonic.
I have a harmonic. The
Yeah.
20
I don't see
megahertz signal
I
is
don't see that
there.
much
It's
at 10
not.
megahertz, though. Yeah, you're right there. You're right on.
Or is
30
it?
mega. Yeah, that's 30 megahertz
Just
exactly.
wondering.
Yeah.
So,
It would be a third harmonic at 10 megahertz.
I mean, I
Just
turn on the
curious.
audio. I hear hum. Do you hear? I don't know
It
if you guys
looks.
hear what I'm
Yeah, I
hearing.
see the hum.
You can see the
Yeah, I
hum.
see the hum. I don't hear the
That seems like it's not a particular, I don't know, but it seems like that's
revvings
not a good thing to have if you're having a harmonic. It should be
synesthesia.
unmodulated. That sounds like your clock may be introducing um, uh, hum into all the receive signals. I mean, I don't know. I don't know how. It's hard to tell. But do you have? Is your clock generator introducing a ground loop in your shack?
It's
Well,
it's
is it?
conceivable. I am not relying on 10 megahertz for anything that's really
Oh,
serious at this point. I could turn it off and see if it disappeared. I'm not out there right now, though. I'm in my
Okay.
house.
No, I don't think you. My point is only that there's things, if you just go look here and turn on audio. I don't know if you guys hear it, but that sounds like
So we don't hear it.
sounds pretty much like white noise to me. I don't hear a lot of 120 hertz kind of. That's another index of.
N5TNL has an interesting suggestion. How about a 60 hertz transformer near a 10 megahertz OCXO with a steel case? Sometimes it can be stuff like that.
Yeah.
Hmm.
Well, in any case, that's
There aren't many 60 hertz transformers left, but yeah.
well, you can. This is. I think this spectrum kind of looks like what you get from the Kiwi. It's I don't know what you see down at you should see WWV down at 60 kilohertz quite clearly on this antenna. Where did I zoom out? Where's
We
60?
got a lot of computers in there. On the left. That's
There it
100
is.
left. Yeah.
Down to the left there.
Yeah, it's in there. It's in there.
Yeah, I thought I was tuned to set frequency. Where does
It's a notch at 175, or is that just between QRM peaks?
Well,
175. Yeah, I don't know what that is. Well, it's
computer power supply is often switched at around 75 or so. Mine's really noisy here.
and look at all those regular peaks over there at the right side of the screen.
Yeah, well, that's a broadcast man.
That's your
Is that
broadcast
AM?
man. Yeah, that's
Oh, I beg
AM
your
band.
pardon.
Yeah,
That's
every 10
I'm
kilohertz.
sorry.
Yeah, this is a pretty
That's AM.
Good 10
pretty-
kilohertz markers, yeah.
This is pretty clean looking low end.
You have a MDB or something near you, 300 and what, 510
300
kilohertz.
I'm not sure what that is.
Well, I think aviation NDB
That's
is
pretty
still operating
stable.
down there, I think.
I wonder what
Well,
the not
NDB, it'll be a carrier with a low level AM CW ID on it.
let's see, zoom in.
Are you near an airport, Mike?
12 miles away.
There you go. It could be hearing one of the markers.
I don't see I would expect WWVB to be stronger than that. So,
looks
somebody
like it's
last week they're back at full power, right?
yeah, I'm surprised they're not seeing. I see there's something in there, but it's it's kind of surprisingly weak for me.
Try going there and using an hour filter. I mean, I'm not sure what the resolution.
Well, I can't. I don't have a good. I only have. I can't guess if I.
Zoom
That's
in
a
and
zoom
use an
in.
hour filter. Yeah.
Okay, so here is if I go to CW. Upper. I don't. Yeah, this is.
CW. Yeah.
Yeah, but I
Zoom
don't.
in.
Zoom in.
I'm zoomed in all the way. That's
okay.
maximum zoom. Another problem with this. So this is
Well,
so the-
remember, I mean, my bins can't go any narrower without me increasing block time. So
yeah, so you don't.
as somebody already said, this is not the right tool for this anyway.
No.
At that level, the right tool is Canoe Radio.
Yeah. Well, this is anyway, you can see, you can see signals going down to I thought it was kilohertz. So if we go down to
Well,
here's
40,
10,
that might be one of the Navy transmitters around about 39 or so.
there's that one in North Dakota, I think it might be
Probably the one
it,
he's hearing. Yeah.
the one on 20.
North Dakota's on 25.
Oh yeah, there they are. You
Well,
ought
I
to
don't
see
know what-
they're running megawatts, right?
Yeah.
Megawatts, yeah.
Well, this is at least the antenna goes down to 20 kilohertz.
Yeah.
Um, I know Glenn's active antenna he's got it's going down to I think 10 hertz to 60 megahertz.
Yeah. Jonathan, you know about these VLF transmitters. I assume they're very frequency stable, both the carriers and the clocks. Can you use them as references down there?
Well, actually, only WWVB. The ones, many of the Navy transmitters have a frequency offset. They are stable, but they have a frequency offset.
So you can't depend on being on their nom. Okay.
Yeah, yeah. The NAA has a frequency offset around 24 microhertz.
Ha! Okay, you would know that.
Yeah.
Okay.
Yeah.
That one would be a challenge for us to
How
measure.
about their modulation clock rate? How accurate is that?
Um.
I know it's MSK. I forget what rate.
Yeah. I measure the modulation phase, and that's pretty stable. That pretty much stays stable throughout the whole.
Well, you must be looking at the average because I mean
yeah.
Frequency is either above or below at any instant, but I guess over time it must average out.
Yeah.
The signal's encrypted, so over a long period of time it would have an equal number of zeros and ones.
Mm-hmm. But yeah, you wouldn't want to use them for references unless you note their offsets.
Okay, but you don't. I guess you're not looking at the modulation. You say you're looking at the average phase, so you're ignoring the modulation.
Right. Yeah.
You're not paying attention to the modulation symbol rate. Okay.
No. No, because this is North Dakota yesterday, and this is actually what here. Let me share this. This is actually what I look at. So this is NML. This was computed with the offset, and the offset is in microhertz as well.
Well, over this time, it would matter, wouldn't it?
Yeah, yeah, and so here, so this measures the carrier phase with reference to a signal from a GPS reference, and this is the modulation phase. So this measures the phase of the modulation and over the whole diurnal. This samples at 5 hertz per second. So it does a measurement and it makes the calculations from 5 hertz per second measurements, and this is
okay.
This is
you
over
mean 5 samples per second. Okay.
Yeah. Mm-hmm.
And the signal actually goes away around before 0400. It goes away completely for you.
This is yeah. Well, I think what happened here is that either the transmitter switched off.
I guess they have to maintain it every so often.
Yeah. Because because if you look at the phase, this is noise, which indicates
Yeah,
that
it's noise. Yeah, it's obviously noise. Yeah.
it locked or it lost the carrier.
I've always wondered, what orders do those sub commanders have if all these stations go off the air? What are their orders? I've always wondered that.
Well,
Stand by.
From what people notice for monitoring these things, so NML goes off normally during the days on, I think it's Tuesdays, and NAA is every Monday.
So they have regular
Mhm.
scheduled maintenance, obviously.
Yeah.
Yeah.
Yep. There's always at least one or two running. But yeah, after you monitor these for a while, you
Figure
could
them out.
figure out their
Now, where did you find this offset? Is this published or is this your observation?
So what I did was it can be calculated from the so this, without the offset, this phase plot will actually roll.
Sure. So, I mean, my question is, did you observe this? Do you calculate the offset, or was that published somewhere by the Navy?
No. This was observed, and
You
what I
derived
did,
it. Okay.
yes.
Okay.
Yeah, actually, Paul Nicholson, the author of VLFRX tools, what he did was he wrote a program to do an
Well, a best fit over some number of days would be best, I guess.
Yeah, the values that I got, they were averaged over the diurnal.
Yeah.
But he, so what he did was he, instead of taking the slope of, say, the whole diurnal, because it's noisy, it does something like it takes multiple slopes and it averages them.
Oh yeah, sure. It's a best fit.
Yes.
That would be, best fit.
Yes, and it actually gives a much more accurate offset. But yeah, this is observed, and then
Yeah.
so then I could observe the offset, and then I could give that to you, and then you could measure this, and you should get the same result. But yeah,
Yeah.
these are,
Well, I don't know. I'm on a different tectonic plate than you. It might be slightly different.
yeah.
That's a joke. That's a joke.
but you could probably get NLK really well too, because you're much much
I've looked. Yeah, the one up in the Northwest is the strongest one here.
Yeah. But anyway, yeah, that's what I measure. You could see in here, there's some small solar flares here. These little peaks, those are small solar flares, but
I
yeah.
wonder what are the commander's orders? I always wondered that.
From what I understand, they're like low speed, like text only messages.
That's right.
But yeah,
I hope their orders are something like service and hook up to our satellites for further instructions. That would make more sense than just launch all your nukes.
Yeah.
Take your thumb off the button.
Yeah.
Yes.
I mean, I haven't really talked to anybody that actually worked on one of these subs. And I don't know if they're obviously technically not allowed to give any details, but
we all know what these signals are for, and I'm always thinking about that when I look at them.
Yeah, I was kind of curious myself. What are these messages? But yeah, we just used the carrier to look for solar flares and GRPs.
No, I understand. The Navy obviously puts a lot of money into these signals and keeping them on the air, so it's obviously very important to them.
Yeah, and I'm really glad that they do, because they also provide other very useful service.
Yeah, now that, I mean, Omega's been off the air for years, but you
Yeah.
used to have that one also. Yeah.
Mm-hmm. And Omega caused a lot of interference. Well, not interference, but if you're listening for whistlers and other,
Oh, yeah.
it could it's noisy, but
Yeah.
but anyway,
I'm gonna sign off, guys. Peace.
Yeah, Mike.
Vote tomorrow if you haven't already done so.
I voted today.
I did too. Oh.
Big crowd too. They say they've been very busy at the library.
I was first in and first out, 8 a.m. at the county courthouse.
Apparently, there's big turnout this year. Hopefully, I hope that means good things.
Me too. We'll know.
Yeah.
2 days
know
from now,
tomorrow. We hope we'll know. We hope we'll know.
We'll reconcile ourselves to whatever it is, I guess.
Yes. Yeah.
Anyway,
Okay.
peace, everybody.
Okay, take care, Michael.
Yeah,
Thanks for working on this antenna thing. I really appreciate it. Yeah, it's good.
No sweat. I always like to learn a lot.
Yeah, well, good. Well, Glenn, I'm kind of twisting Glenn's arm, but I think, this discussion and what we just saw tonight suggests to me, that Glenn's antenna, I'm sure would be superior, but the thought of putting up a 23-foot tall whip antenna, fiberglass whip, may be even harder than an 8-foot vertical for the DX engineering. So and then we'd buy all of the need to support and all that stuff. And I'm
Right. If DX Engineering provides it, we're buying that already. Yeah.
Yeah, that's it. Yeah. And I think we have but I think I'm looking forward to getting one to you, just as a way to, it would allow us to calibrate against, known.
Yeah. Good point. All
Okay.
right. Good night, everybody.
Okay. Good night, Michael.
Good night.
Good night. I'm gonna sign off too. Thank you, everyone.
Well, thank you for hosting all of this.
You're welcome.
And I don't know what else is I have to talk about. But any other subjects, Dave? Who's the Strega?